Welcome to part 2 of this video. Same topic, ozonolysis, but our focus now will be on solving exam questions. So we're going to solve an exam question which was asked on ozonolysis in 2023 final exam. Right, let's check out this past paper. So we've done ozonolysis in the first part. Now we are just focusing on solving an exam question. So this was chemistry 2105 as the code there shows. And in this paper, the question was asked on question number 2. It was question number 2, the one I had to show there. I indicated it. So this was the question which was asked. Let me just remove this. Okay. So the question was predict the product of the following reactions and give a detailed mechanism for the reaction. Okay. Predict the product of the following reactions and give a detailed mechanisms for reactions 3 and 5. Okay. So our reaction is this one, which we are concentrating on. This is ozonolysis. So let's solve this particular exam question. So what we have is this compound, then it is reacting with the ozone there, then with CH2, Cl2 at this temperature negative 78 degree, and methyl sulfide as another reagent rather. So I'll use this board here. Okay. Alright, so let's now get into it. So the question was something of this kind. Then we have okay, let me just so this was the question. Then it is reacting with O3, which is just ozone, then with CH2 Cl2, then the temperature is at 78 degree, of course with a methyl sulfide like that. Then the temperature was negative 78 degrees Celsius. So we are told to find the products here. So the question did not necessarily ask about us making the mechanism, but for the sake of understanding it better, so that we know what everything is coming about from rather, we need first to know the mechanism. So the question did not specify whether to write the mechanism on part number 4 rather, but it was just requiring us to write the mechanism on part number 3 and 6. But this is something you need to understand before you even write the product. So no wonder we are drawing the mechanism. Okay, so that is the question we've been given. So the first thing, I'm going to write this same I'll write this, then it is reacting with ozone. We are using your ozone to break this compound, so I'm going to write ozone like this. So the structure for ozone, in the first story we said it has this structure, because that oxygen is bonded to three things. Now it has a positive, then that one will have a negative charge. So now let's write the first thing that happens in this reaction is that this bond is going to attack this oxygen here, because this oxygen also has lone pairs of electrons. It can make, this oxygen with this oxygen as a double bond, this bond can break, donating electrons to this oxygen which is positively charged. Then the negative charge will be neutralized. Then this oxygen also on top has some lone pairs of electrons, so they'll be able to attack the carbocation there. Okay, they are able to attack that carbocation which is formed. Then what is going to be produced is actually this structure. So we have that structure like that, with that. Then we say that carbon is going to react, that carbon is going to react with this oxygen which is there. So we must have a carbon attached to this oxygen. Then there are three oxygens like that, another oxygen like that. Then they are bonded to that carbon like that. So this is the first step which occurs in this reaction of ozonolysis. So this is what we have. Then the next thing which we are going to do here is that there will be bond breaking. So this oxygen here has some lone pairs of electrons, so it can break there, donating the lone pairs of electrons to this side. So there will be a double bond which is going to be formed here. Okay, then the other thing is that this bond is going to break, donating electrons to that bond, therefore forming a double bond at this point. Then this oxygen also has lone pairs of electrons, so this bond can break, forming donating electrons to this, hence becoming negatively charged. So this is what really happens. Then when this happens, we are going to form this, so I can get rid of what is on the top. So we are going to form this. So this bond had to break, and the bond there is broken, so we're going to form this structure. There is a double bond, so I'm going to have a double bond there, then attached to this oxygen, in fact to two oxygens. So we're going to have that oxygen with another oxygen. So that oxygen, because it's the one which is giving away the electrons, so it remains positive, Then this oxygen there, because it is receiving more electrons, it will become negative. Then plus the other structure, it is this group there, the cyclopentane, which is like that. So it is this cyclopentane which is since this bond is being broken and donating electrons to this bond, this cyclopentane will be bonded now to oxygen with a double bond there. So I'm going to have a cyclopentane bonded with an oxygen. So this is what we have. Then the next thing, these two reactants are going to react by themselves. So there's a reaction in chemistry known as an Haricot reaction. So in this reaction, it is whereby you are forming a product, then the product which is being formed again, it is acting as a reactant to form another product. So it is a similar scenario in this case. So this is what we have. Then these two are going to react. So how the reaction really take place is that we have these two structures which are formed. So they are going to react again by themselves. So that carbon which is there, that double bond which is there, is going to attack the carbon which is there. Okay. Okay, so that bond which is there is going to break, attacking the carbon which is there. So actually the first step which should take place is that the bond here, let me use a different ink. So the bond here will break, donating electrons to that positive charged oxygen, hence neutralizing it. Then the next thing which happens that that oxygen which is there with a negative charge has some lone pairs. So these lone pairs are able to attack that carbon which is there. Then what really happens is that it looks like it is this bond which is breaking in order to attack the carbon which is there. But in the actual sense, it is this oxygen rather, with lone pairs which attacks the carbocation which remains here after the bond has been broken. Okay, so that is how the reaction takes place. So we're going to have that carbon attacking that oxygen rather attacking this carbocation which is there. So what is now formed is this structure. So I'm going to have this structure like this. So it will be this chain which is there. Okay, so we're going to form this with an oxygen there, then another oxygen, then that carbon has to react with that, has to bond with that oxygen. So we have that. Here we have a carbon, then which is attached to this carbon is the one which is attached to this ring, like that. The cyclopentane. Then this carbon which is here on this cyclopentane, it is the one which reacted with this oxygen which is here. So this carbon should form a bond with this oxygen. Then there will be a bond. There was a bond which formed between the oxygen and the carbon. So we formed this ring which we have here. Then the next thing that really happens is that there will be this methyl. in that reaction we had methyl sulfide. So what really this methyl sulfide do is that it grabs the oxygen. Okay, so it's going to grab this oxygen which is there. Then when it grabs this oxygen, we're going to form something like methyl 2 sulfide with an oxygen there. So it's going to form a compound which looks like that. Okay, so that is one thing we must know here. When this methyl sulfide grabs this oxygen, so we know that this oxygen has some lone pairs of electrons. So these lone pairs of electrons can now be able to be donated. Okay, so the lone pairs of electrons can now be donated to this. Okay, in the actual sense, this oxygen, once it is grabbed, then this bond can break here. So when this bond breaks, it is able to donate electrons to this other oxygen which is here. Then the next thing which happens here is that this bond also can break. Okay, so that oxygen, let me use a different ink. Okay, right, so this is the reaction which is taking place. The methyl sulfide attacks that oxygen and grabs the oxygen. Then this bond between oxygen and oxygen, it will break. Then the lone pairs of electrons will go to this oxygen which is here. Okay, then when that happens, we are going to have a structure which is going to be formed. So the first thing I've said, this sulfide, methyl sulfide, attacks this oxygen, grabbing the oxygen. Then this bond is going to break, taking the electrons to this oxygen which is here. Because this oxygen now have more electrons, it has more electrons now, so it has a negative charge. It is going to donate some electrons, forming a double bond which there. So the first thing we're going to have will be this cyclopentane with a double bond here. So it is going to form a double bond with oxygen there. Then the other thing we're going to produce is that since this cyclopentane has formed a double bond which is a cyclopentanone, okay, a cyclopentanone. So this structure is a cyclopentanone because it is a cyclopentane with a carbonyl group attached. So no wonder we're calling it cyclopentanone. So the other thing is that when this happens, this bond can also break, okay, taking the electrons to that oxygen. Because this oxygen now have more electrons, the electrons can now form a double bond there. So we are going to form another structure which looks like this. So we have a methyl, that methyl, then bonded to that oxygen which is here, bonded to that oxygen like that. So there's a double bond which is forming here with oxygen. So that is the double bond I've put there. Okay, and we know that since this carbon has 3 bonds, 1, 2, 3, it means that the other element which is there, it is just hydrogen. That is how we write the bond line structure. So we have formed these 2 compounds now. We have a cyclopentanone and also an aldehyde here, acetylaldehyde. Okay, so we have this structure which is a cyclopentanone. which is this. So this is the structure we are going to form in this reaction. So they said write the products which are formed in this reaction. So these are actually the product which are formed. Okay, so this is the reaction of ozonolysis. So this is simply ozonolysis. So we are forming these products by breaking this substance using ozone. Thank you for watching, and don't forget to subscribe. Okay. So if you found this to be helpful, don't forget to like, share, and also subscribe. You can contact us if you really need to subscribe to the Particular Study Hub app and also the website. Here is our contact and also our email. If you want study materials, 12 videos for A level natural sciences, and also for IGCSE Cambridge International Curriculum for junior secondary, senior secondary, and also for secondary. Thank you.